Course 3, Lesson 110, we are taking repeating decimals and changing them into fractions. We have done just the opposite of this many times, taking fractions and turning them into repeating decimals, but it is hard to go backwards, and that's what we're going to practice today. So first of all, how do we normally convert fractions to decimals? So like 3/11ths, we would take 3 and divide it by 11. So in this case, we would need to add a 0. Goes in there 2 times, so we would have an 8 left over, and bring it down again, and we could get that in 7 times. And we would have a 3 left over again. And this would continue on, and we would get 0.27 repeating. Now we need to figure out how do we go backwards to find the fraction form of a repeating decimal. Some of them we know by sight, some of them we don't. Well, let's figure out how do we get from 0.27 back to what we just had, 3/11ths. It's kind of a funny way to go about this, but we are going to create 2 equations. So number 1, we're going to make our variable, just any variable, you can use f, that's what we use here, equal to the decimal that we are using, so 0.27. Number 2, based on how many numbers are repeated right here, we are going to multiply our variable by that power of 10. So in this case, we have 2 repeating decimals. We are going to multiply by 10 squared, or 100. So we now have actually 2 different equations. We have our original one, f equals 0.27 repeating, and we have our second one, 100f equals 27.27. Now we got that from taking f equals 0.27 repeating and multiplying each side by 100. We can definitely see where we get the 100f. It's a little bit harder over here to realize that if I were to take this decimal and basically multiply it by 100, makes it look like we're moving this back twice. Well, we now have 27 as kind of my big number, my outside number, point. We still have all of these 27s repeating afterwards. So by multiplying by 100, I now get 100f equals 27.27. We're going to use actually 2 equations to solve this, and we actually subtract the 2 equations. We line them up, 100f equals 27.27 repeating minus, and we can imagine this as like a 1f equals 0.27 repeating. What happens when we subtract these is if I have 100f minus 1f, I get 99f. And if I have 27.27 repeating, and I'll write out some of these repeating numbers, minus 0.27 repeating, it ends up that when we subtract these, every single one of those 2s and 7s in those decimal places cancel out. It's going to be 0 over here. But we still have 27 minus 0, so we get 27. Well, to finish this off, we have 99f equals 27, so I divide by 99 on each side. But we don't leave it like that. We reduce a little, by 9 in particular, and get 3 over 11. The exact fraction that we started with up here to get 0.27 repeating. So let me show that a couple more times. It's hard to see on the first one, so let's try again. Okay, so our variable equals 0.16 repeating. That is my repeating decimal. So here's my first equation. F equals 0.16 repeating. Now, since I have 2 numbers that are being repeated, I'm going to multiply both sides by 100, 10 squared. So I'm going to do f equals 0.16 repeating and multiply this side by 100 and multiply this side by 100. Means that I get 100f, just like before. And in this one, on the right side, I am going to move that decimal back twice and get 16.16 repeating. And I'm going to subtract just like before. 100f minus f is 99f. And when I have this 0.16 minus 0.16 repeating, both of those are going to cancel out, and we get 0 left in the decimal and 16 in our whole numbers. And then I go ahead and divide. divide by 99 on each side. 16 divided by 99. And I look at that 16 over 99 and I say, yeah, that's the simplest I can go. That is actually my fraction for 0.16 repeating. Okay, how about one that we're a little bit more familiar with, but it only has one number that's being repeated? Well, I'm going to do the same way, and if you know what this is going to come out to be, you can check to make sure that this method works. But I'm still going to have f equals 0.8 repeating. And then instead of multiplying our sides by 100, I only have one number repeating, so I'm only going to multiply it by 10 actually. And I get 10f equals, move that decimal back once, and I get 8.8 repeating. Still going to subtract, and my 8's repeating are going to completely cancel out because I'm subtracting, and I just get 8 on the right side equals 9f. Divide by 9 on each side, and I get f. Our number is 8/9. That is our fraction for 8 repeating. Okay, 0.8 repeating. I'll give you a little bit of a hint. If it is one number repeating, like let's say 0.5 repeating, how we would show this as a fraction is just that number 5 over 9. Okay. If it's a couple numbers repeating, like 0.13 repeating, I would show 1 and 3, 13 over 99. Or maybe if I have 0.134 repeating, all three of those repeating, then I would show that as 134 over 99. Now, I will tell you in this case, there are a lot more of them, that will reduce down to something over 11. My 11s repeat quite a bit. And so we see that in something like 0.36 repeating. 36 over 99 reduces to 4 over 11. So we see a lot of those. But that's kind of like the gist of what's happening. But the reason that that is happening is because of this process. Now, a lot of them won't work out quite like that. Okay, we'll try a couple more, but some of them are not going to see, you're not going to see this, this perfect 99 or your perfect 9s. Okay, so, oops, this should have another 9 on it. There we go. So let's figure out if we can do this one. So our first equation, f equals 0.72 repeating. Then we multiply each side by 100 and get 100f equals, remember that's 100 because both 2 are repeating, and I get 72.72 repeating. Well, when I subtract these, I get 99f equals, and that's going to be 72. I divide by 99 on each side, and I get f is equal to, well, both of these can be divided by 9, so I get 8 over 11. There we go. So that repeating decimal as a fraction is 8/11. What if we have 2 decimal places, but not all of them are repeating, like this one, 0.83 repeating? You might recognize this as a very common fraction that we have repeating. So I always go based on how many numbers are repeating. So instead of multiplying by 100, once again, I'm going to multiply by 10 since there's only one number repeating. So let's try it out. F equals 0.83 repeating. And we have my second equation, 10f equals, and remember I'm just going to move my decimal place once for 10. So I get 8.3 repeating. Now, this doesn't look quite the same. We still get the 9f, but this 0.83 and this 0.3 repeating, those aren't the exact same thing. So when I subtract them, what do I do? Well, the best way to explain this is to show some of those repeating numbers that we have further along. So this is 0.833 forever and ever, right? And this other one is 0.8333 all the way forever. Well, all of these 3's that I have, basically from here on, cancel out when I subtract. 3 minus 3 is always going to be 0. And then I'm left with this 0.3 and 0.8. Well, to subtract, I need to still borrow just like always. So I'm going to borrow from this 8 and get 7. 13 minus 8 is, we bring that down the decimal point of 5, and 7 minus 0 is 7. Ends up that we get 9f equals 7.5. Divide by 9, and we're almost done. But I don't like to leave decimals, no mathematician does, like to leave decimals in a fraction. There are very few opportunities for that. So I'm going to get rid of that decimal by, if I were to multiply each of these by 2, I would get some whole numbers, like 15 over 18. That's an equivalent fraction, totally allowed to do that. And then I can reduce from there to 5, 6. Hopefully you thought of this before we actually found it, but yes, 0.83 repeating is 5/6, proven by our method up here. All right, we're just going to do a few more here and in context. So change the percent to a repeating decimal and then to a reduced fraction. So this percent right here, we would move our decimal back, divide by 100, and get 0.3 repeating. Well, just to prove that the method works, you all know that this is 1/3, but to prove it works, we're going to have our first equation, 0.3 repeating. We're going to multiply that by 10 to get 10f equals 3.3 repeating, and we subtract 9f equals, that cancels out, and we get 3. Divide by 9 on each side, and I get f equals reduced to 1/3. So let's try this next one. It's a percent right now, 12.12 repeating. Put it as a decimal, we get 0.12 repeating because we moved it back twice since we are dividing by 100. Now that we have our repeating decimal, I can put one equation as f equals 0.12 repeating, and I multiply by 100 this time, since there's two numbers repeating, to get 12.12 repeating. And we subtract. 99 equals 12. 99f equals 12, divide by 99, and I get f equals, well, I can reduce each of those by 3, so I get, let's see, 4 over 33, and that's all I can reduce it to. So 12.12 repeating percent is 4 over 33. All right, now with probabilities, this can definitely come up, and we use them to predict what might happen in the future. So if I have the probability of rolling a 12, the sum of 12 with two number cubes, that is 0.027 repeating. About how many times would we expect to get a sum of 12 to come up with 180 rolls? First, we need to change this to a fraction, so we use our method. F equals 0.027 repeating, and then since only one number is repeating, I'm just going to multiply by 10. Which just moves the decimal once. So I get 0.27 repeating. Now to show this one more time, I'm going to put all of these numbers that I have actually behind it that we normally show with that repetent bar. And so that when we subtract, I get my 9f, and I start from over here. I say 7 minus 7 is 0. 7 minus 7 is 0. 7 minus 7 is 0. 7 minus 2 is 5. 2 minus 0 is 2, and I have my decimal point. So that now 9f equals 0.25, then I divide by 9. Once again though, it's not nice to have decimals in a fraction, so I'm going to multiply this by 4 to get it to a whole number, and I get my final fraction as 1 over 36. To finish this and figure out what we would expect to happen, if I have 180 rolls and I know that 1/36 of them are going to be a sum of 12, I would multiply this together and get 5. We would only expect, if the world was a perfect place with perfect probability, we would expect to get 5 times of getting a sum of 12. All right, this is our last one. So, probability of rolling an 8 with two number cubes, sum of 8. So let's change 0.138 repeating to a fraction. So f equals 0.138 repeating, and only one number is repeating, so 10f equals, move that decimal over once, and I get 1.38 repeating. I'm going to write down some of those 8s that we actually have here, just to make it easier when we subtract. I get 9f equals, well, 8 minus 8 is 0, 0, 0. Okay, we get all zeros up until this point that I have 8 minus 3 is 5. 3 minus 1 is 2. I have my decimal place, and 1 minus 0 is 1. I divide by 9, and I, just like before, need to get these to whole numbers. Well, I'm going to multiply by 4 over 4 to do that. My equivalent fraction then is 5 over 36. So it's a 5/36 probability of rolling an 8. So when I do 180 rolls, 5 out of 36 times 180 equals, I believe, 25 times of getting a sum of 8 with those two number cubes. All right, so I hope that with this lesson you're able to now take those kind of difficult repeating numbers and change them into fractions. I hope this video was helpful for your homework and for studying.